Hello, good morning friends. Myself Mrs. Sudha Survase. Today what we will look for is time response of first order system. Obviously if we have to look for response, we have to think of the inputs. So what we are looking for in today's session is the time response of first order system to various standard inputs like of unit impulse or unit step or unit ramp. So before starting for what will be the output, if input are those standard signals, we will make an attempt to write for transfer function of first order system. So shown here in the figure is a first order circuit, which is a RC circuit. So we have to find out its transfer function. As we all are aware of, that transfer function is nothing but transform of output to transform of input. I can write for the transfer function of the circuit as transform of V0 of t, that is nothing but V0 of S, to the transform of input signal, which is Vi of S. So we have to write an equation for V0 of S and we have to write an equation for Vi of S. To write this equation, I will apply KVL to the given circuit. So apply KVL to the given circuit. And what equation we can write for is the input signal Vi of t is equal to R into I of t plus 1 by C integration of IT dt. Right? As we are aware of, the voltage across resistor is I into R and the voltage across capacitor is 1 by C integration of I dt. So I can say total applied voltage is equal to VR plus VC, and the same equation we have written for. Now assuming zero initial conditions, as we are considering for the capacitor, very important is I have to assume some initial conditions. So I will assume for zero initial conditions, I can write for taking its Laplace transform. I'll say this is equation 1. So taking Laplace transform of equation 1, I can write for Vi of S is equal to R into I of S plus 1 by C into S I of S. Now I of S is common. I can write same equation as Vi of S is equal to R plus 1 by Cs into I of S. Similarly, I can write equation for the output voltage. As we know that output voltage is nothing but the voltage across capacitor, I can write for V0 of t is equal to 1 by C integration of I of t dt. So again taking its Laplace transform, I can write for I can write V0 of S is equal to 1 by Cs into I of S. So to write the transfer function, I will take the ratio of 3 by 2 and hence I can write for transfer function is equal to 1 by Cs into I of S divided by Vi of S, which is R plus 1 by Cs into I of S. So this term gets cancelled and what I can write for is 1 by Cs divided by RCS plus 1 divided by Cs. Again Cs in the denominator will get cancelled for, and I can write for transfer function as 1 divided by 1 plus RC into S. So this is nothing but the transfer function of first order system. If I'll assume that the system has gain K, then I can generalize statement I can make for first order system, it is K upon 1 plus RC into S, whereby RC I will say is time constant of the system, and if tau is the time constant, I can write for the transfer function as K divided by 1 plus tau into S. So this is the desired answer, and we have find out for transfer function of the first order system.